2. So we went over yesterday number 1, number 2, number 3, number 4, number 5, 6. We skipped number 7. So go ahead and make sure you guys cross out number 7. Número 7. Ouch. And then we went on to the binomial theorem, number 8. So therefore, we are now on numero 9. So number 9. So let's go ahead and read this one. It says to use the binomial theorem to expand each power of a binomial. So again, we're using the binomial theorem. We now have the example of 2x minus y to the power of 4. So yesterday we went over the binomial theorem. We had to use a Pascal's triangle. So what do we know about the Pascal's triangle? How does it start? 1 and then 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. The next row. 1, 5, 10, 10, 5, 1, and so on and so forth. Remember that our first row is always going to be row 0, row 1, row 2, row 3, row 4, and row 5, and so on and so forth. You can continue going on and adding more rows if you need to. However, by looking at our example, which row are we going to use? 4. So here's my row 4. How do we know? The exponent to our beautiful binomial has the power of 4, which means that we're going to go ahead and focus on these beautiful coefficients. Okay, so what do we do next? We write them out. So we have 1, a little bit of space. My next row is, or my next term, 4, a little bit of space, 6. Move this to the side so it can move. There you go. A little bit of space, 4, a little bit of space, and the last coefficient is beautiful 1. Okay, now remember that there's 2 terms. My first term is what? 2x. So I'm going to write 2x, parentheses, 2x, parentheses, 2x, parentheses, 2x, parentheses, and the last term, 2x, parentheses. These are my 2 factors. That x looks like something else. There you go. All right. My second factor is what? Negative y. So include the negative sign, guys. Negative y. Let's keep on closing. Negative y. Negative y. That's a y. Negative y. Otra vez. Negative y. And the last one, negative 1, my last factor. Okay, all right. Next come our beautiful exponents. So what's our highest degree? 4. So our first factor that we place there has to have the highest degree, which is 4. Then comes 3, 2, 1, and 0. Remember that it descends, it goes down. And then the next factor, it ascends, starting from 0. So it's 0, 1, 2, 3, and 4. Now, the reason it's 4, the highest, is because it's to the power of 4. So if it would have been to the power of 5, we would have started with 5. If it would have been to the power of 6, we would have started with 6, and so on and so forth, okay? So it all depends what our beautiful exponent. Okay, now the fun part begins. We have one term right here. Let's start simplifying that first term. 1, and then we have 2x to the power of 4. So 2x to the power of 4 is now what? So 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is 16x to the power of 4. Anything to the power of 0 is what? 1. So this is 1. So we're going to multiply 1 times 16x to the power of 4 times 1. It's going to give us 16x to the power of 4. All right, step by step, guys. Now, my next term is right here. Let's compute this part right here. 2x to the power of 3. It's going to be 8x to the power of 3. Negative y to the power of 1 is going to be negative y. And it keeps on closing my y's. So this is now 8x to the power of 3, negative y. So let's go ahead and multiply that by 4. So 8 times 4 is negative 32, because we're multiplying 4, 8, and negative 1. The negative 1 that's right here in front of my y. So negative 32, x to the power of 3, y. Okay. Letting you guys digest this. Okay, next term. We have 2x to the power of 2. This is going to be 4x to the power of 2, negative y to the power of 2. So it means that we have negative y times negative y. Beautiful, y to the power of 2. So this is now y to the power of 2. Jacob, put your phone away, please. Thank you. So we're going to go ahead and multiply 6 times 4 times that 1 has their coefficient into y. So we have positive 24, x squared, y squared. Okay, so we have 1, 2, and 3. We're missing 2 more. Okay, so let's go ahead and do the next one, the fourth term. 2x to the power of 1. 2x. Go ahead. And then we have negative y to the power of 3. That means that we have another negative y multiplied together. So we have negative y times negative y times negative y. Negative y to the power of 3. So again, we have 4 times 2 times that negative 1 in front of our beautiful y. Negative 8x. Y to the power of 3. And the last term, very carefully, guys, do every factor by itself if you need to separate each other. So we have 2x to the power of 0. This is going to be what? Beautiful, 1. Remember that anything to the power of 0 is always 1. And the last one, we're multiplying y one more last time. So we have negative y times negative y times negative y times negative y. Y to the power of 4. So this is positive y to the power of 4. So this is 1 times y to the power of 4. Positive y to the power of beautiful 4. And there you go. Again, take it step by step. Multiply everything together carefully. Do it piece by piece, term by term. Okay? Very careful with your computations here. Not too bad, right? Okay. Everybody has it? No. Thank you. Yeah, okay. Everybody has this, making sure everybody has time. Okay, let me go ahead and clear. So that was the binomial theorem. So we're gonna go ahead and now go on to beautiful factoring. We're gonna go ahead and practice one of our steps. We're gonna start with grouping. So grouping. What do you guys remember about grouping? We're going to go ahead and group our first 2 terms and our last 2 terms. So by grouping, if we have 4 terms, group your first 2 terms, last 2 terms. All right. Now, we're going to go and factor by using the GCF now. So what do we have in common in my first group? X to the power of what? Beautiful, 2. So let's go ahead and take it out. Let's factor it out. So what times x squared gives me x to the power of 3? X. And then what times 7x squared gives me, what times x squared gives me 7x squared? Positive 7. All right. My second group, what do I have in common? My beautiful 6. Let's go ahead and factor it out. I'm left with x and 7. What do you guys see in common? X plus beautiful 7. So we're going to go ahead and write x plus 7 because we have those two factors in common, right here and right here. And we're going to go ahead and write what we have left over. So we have x squared plus, beautiful, 6. Now remember that if they're adding, that's all we can do, guys. We can't factor it any further. So therefore, we have x plus 7 times x squared plus 6. If you happen to have the factors turned around, guys, that's the same idea. We can go ahead and have that as well as a result. Yes, Carlos. They have in common, for example, my first term, I have x times x times x, right? My second term, I have 7 times x times x. So the factors that I have in common are x and x, x and x. So that's why the x squared comes out. And we're left with 1x and then the 7. So that's what we have in common. We take it out, and the same thing happens for the second one. We have 6 times x, and the second one plus 6 times 7. So the factor that we have in common are 6 and 6. So 6 comes out, and we're left with x plus 7. Let me see if an image. So if you need me to expand it out, I can go ahead and expand it for you guys to understand. Okay. All right. Everybody had that? Sorry, guys.
Yes.
Any more questions? Okay. Let's see. Número 11. Number 11. Do you guys want to try this one on your own?
No.
So we're going to go ahead and factor the polynomial by grouping. This time we have a different example. We have 8x to the power 4 plus 16x to the power 3 minus 27x minus 54. Make sure that everything's written in beautiful standard form. Okay. All right, listos. So what do I do by grouping? First two groups and second two groups. So what is my GCF for my first two groups? 8 and what else? X to the power of 2. Okay, so take it out. 3, sorry, 3. Woo. A ver, what do we have left over? We took out the 8, we took out 3 x's, so we're left with 1x, and this last term has to have 2. Okay, perfect. Now let's see, what do we have in common in the second group? 27, but we have a negative coefficient, so therefore, negative 27. We're left with x plus beautiful 2. What do we have in common? X plus 2. And we're left with 8x to the power of 3 minus 27. All right. So once we get here, we see that we have x to the power of 3 minus 27. I'm not going to factor it further. I'm going to go ahead and leave it as is, guys. So we have x plus 2, 8x to the power of 3 minus beautiful 27. So not too bad, right? Okay. Okay, everybody has this? All right, moving on. Now we're moving on to our next topic. Our beautiful long division, guys. We have to divide our beautiful polynomial 6x squared minus 9x plus 10 divided by x minus 4. Now, do you guys remember long division? Yes, Ms. Vasquez. Okay, perfect. Can we do a synthetic? No, this one has to be by using long division. So we have a little house. So let's go ahead and create a little casita. All right, what goes inside and what goes outside? Okay, x minus 4 is outside. X minus 4. And inside is 6x squared minus 9x plus 10. Remember that if there's a term missing, you have to write a placement for it. So do we have any missing terms? We have x squared, x, and our beautiful constant. So no, nothing's missing. All right, now we're going to go ahead and look at the first two terms. My first term is 6x to the power of 2 and x. What do we need to multiply x so that it can become a 6x to the power of 2? 6x, so that's going to be our first value, 6x. That means that everything outside is going to be multiplied by 6x. Let me go ahead and move this. For some reason, it doesn't want to disappear. So remember, we read a minus sign, our parentheses. Now let's go ahead and multiply 6x times x, 6x squared, 6x times negative 4, negative 24x. Okay. What happens with the negative signs, guys? I need to distribute it into inside. So we're going to do that, keep, change, and whatever it is. Okay. All right. So let's go ahead and do this row. What happens to my first two terms? My first term? They cancel out. That's the purpose of it. We're left with negative 9x plus 24x. What does it give us? 15. There you go. 15x and bring down our beautiful 10. Okay, perfect. Ahora, we have a new term that we're going to go ahead and focus. We have our first term now here, 15x and x. So what do we need to multiply x so that it can become a 15x? 15. So we're going to multiply by positive 15. So again, I'm going to do this one in blue so we can do the next row. Negative. Remember that it's a parentheses, 15x. And then 15 times negative 4. There you go, 60. Okay, perfect. All right, do your beautiful magic. We're going to go ahead and distribute that negative sign. Change the signs inside. We should have the opposite signs for the first term. So we have 15x plus negative 15x. This goes to 0. We're left with 10 plus 60. 70. Ahora sí. Can we multiply 70 or x to become a 70? No. So we already have a variable. We are not left with any more powers to the variable. So we stop. How do we write this? So 6x plus 15 plus. Let's call for Julian apple pie. Ahí está, 6x plus 15. What's our remainder? 70. And what's our divisor? X minus beautiful 4. We got this, guys. We got this. Come on. Can I clear? Everybody has it. Beautiful. Okay, clear. Here we have it. Eric, did you need it? Okay. Okay. All right. Number 13. Now let's go ahead and do synthetic division, guys. This is your favorite method. So this one, we do have a house, but what do we do to the house? We turn it upside down. So let's go ahead and turn it upside down. Again, we have to make sure that we look for missing terms. So let's see, x to the power of 2 minus x plus 9. Are we missing any terms? No, so we're going to write just the coefficients. So we have 2, negative 4, and 9. Now, I'm dividing by x minus 3. So what happens to that beautiful negative 3? We make it to the opposite sign. So if it was negative inside of your beautiful factor, we're going to make it positive or the opposite sign. So if it was positive, it becomes negative. If it is negative, it becomes positive. So in this case, it becomes a positive 3. All right. Now, remember that we always bring the first term down. So bring it down. So now we're going to go and start doing the fun part, which is multiplying. 3 times 2 is 6. So we're going to go and write the result right underneath the next term, the next coefficient. Combine. So negative 4 times, negative 4 plus 6. Beautiful 2. 3 times 2, again. 6. Combine, I get 15. Positive 15. Now, is this a factor? Remember that if it was not 0, it's not a factor. So therefore, let's go ahead and write this as a beautiful coefficient or a beautiful term. So this is our highest degree, power of 2, which means that this one has to be a power of 1. This is our constant, and this is our beautiful remainder. So we have 2x plus 2 plus 15 divided by x minus beautiful 3. So again, this is our divisor, what we're dividing by. This is our remainder, so therefore we write whatever we're dividing by underneath the remainder if it's not 0. Okay. Again, my highest degree is 2, so this one has to be a power of 1. The next one is a power of 0, but what do we say anything to the power of 0 is equal to? 1. So 1 times 2 is 2. So that's why we don't write the exponent of x0 or x to the power of 0. Okay. I'm just explaining to you guys what happens algebraically. All right. Everybody has this. Any questions on this? Long division and synthetic division. Bless you. All right. Moving on. Now we're going to rational expressions. This is what we recently did. So I hope it's fresh in your guys' mind. All right. So my rational expression, let me go ahead and write it down. Let me choose a different color. Okay. So I have 2t squared minus 6t divided by t minus 3. So we're going to go ahead and simplify and also identify the excluded values. So remember that my excluded values, what do we have to make equal to 0? The denominator, right? So my denominator here in this case is t minus 3. So we want to make sure that we find what makes this equal to 0 so that it becomes undefined. So we exclude it. We not include it in the beautiful section. So we have a one-step equation. We're going to add 3. So we have t equals 3. So in this case, t cannot equal 3 because that's an excluded value. Okay. Ahora, back to simplifying. We're going to go and factor both my numerator and my denominator. My numerator, what do I have in common? 2t. Let's go ahead and take it out. 2t. We're left with t minus 3 over my beautiful denominator. That's it. I cannot factor any further. So what simplifies? The t minus 3. And we're left with? So 2t is my beautiful simplification where t cannot be equal to beautiful 3. Yay. Not too bad, right? I feel like these are too easy. I should put a higher power. No. I should give you guys something you have to like factor using all the methods. I mean, everybody has this. A ver. Jacob, do you have this, mijo? Yeah. Write it down, mijo. Okay, let me go ahead and clear. Let's move on, guys. We're almost done. Now we're going to go ahead and add our beautiful rational expressions and identify the undefined terms or the excluded value. So anytime you see undefined terms, guys, or undefined values, it's another word for asking you to find the excluded values. Okay, so I'm going to go ahead and focus on adding these first. Okay, so let's go ahead and focus on that. So I have x plus 3 x minus 4 plus negative 10x minus 23 over x squared plus x minus 20. So first things first, I'm going to go ahead and factor every single part, guys, numerators and denominators. So let's go ahead and see. Can I factor any further x plus 3? No, so I'm going to go ahead and leave it as x plus 3. Can I factor any further x minus 4? No. So I'm going to leave it as is. Can I factor any further? Let's see, negative 10x minus 23. Yes. What can I factor out? We can take out the negative. Let's take out the negative again. Okay. So we're left with 10x plus 23. And my denominator here, x squared plus x minus 10. What method do you guys want to use? Power Ranger. Okay, so two numbers that multiply to negative 20 and add up to 1. 4 and 5. Which one has to be negative? Negative 4. So these are going to be, since my leading coefficient is 1, I have x minus 4 and x plus 5. Ahora sí. My next step, guys, is to find my LCD. So again, my LCD, my first denominator is x minus 4. And my second denominator is x minus 4. And what? And x plus 5. So what is my common denominator? My least common denominator. What do they have in common? X minus 4. So I'm going to include x minus 4. What do they not have in common? X plus 5. So I have to include x plus 5. So this is my LCD. So my first fraction, guys, doesn't have it. So I'm going to go ahead and write it. So x minus 4, x plus 5. My numerator is what? X plus 3. Since it has it now in the denominator x plus 5, I have to include it on my numerator since I multiply both top and bottom. My second fraction already has it, so I don't have to do anything to that second fraction. So 1, 10x, sorry, 10x. Am I going too fast? 10x plus 23. X minus 4, x plus 5. Remember that it had to be, my LCD had to be x minus 4, x plus 5. My first fraction was missing x plus 5. So I have to multiply x plus 5 on both top and bottom. That's where I get this part right here. That's where the x plus 5 comes from. My second fraction already has the 2 factors on my denominator, so I don't have to do anything to it. So I just leave it as is. The only one that I have to modify or fix is basically my first fraction. Now, from here, we're going to go ahead and simplify our numerator. I always tell you not to, guys, or to just combine everything like terms, but since there's many terms that need to be combined, I am going to FOIL out. So multiply. Let's go on to the next step. So x times x is x squared. X times 5. 5x. And then 3 times x is 3x plus 5x is, so it's plus 8x. And the last two numbers that we have to multiply are what? 3 and 5, which is 15. 15x. We're left with our beautiful denominator, x minus 4, x plus 5, plus negative 1. 10x plus 23, x minus 4, x plus 5. Now notice here that my negative 1 is outside, guys. I'm going to go ahead and put it back inside You don't have to always take it out. I don't know why it deletes everything. Let me rewrite that. I multiplied it back inside. So negative 10x, and that's it, 23. Now, what I'm going to do is I'm going to go ahead and combine like terms. So what terms combine? 8x and negative 10x. So let's go ahead and combine those two. So I'm going to write my first term. Let me bring it down here. X squared, 8x plus 10x, negative 2x, and then I have 15 and 23. Beautiful, 38. Yeah, negative 23. I didn't change the negative sign. So therefore, 15 plus negative 23, negative 8. Over, leave your denominator factored, guys. We combine like terms, so now we can go ahead and combine everything in one single fraction. Okay, so let's do one more Power Ranger method. So let's go ahead and factor those two numbers that multiply to negative 8 and we'll add up to negative 2. 2 and negative 4. Let's go and check. Negative 8, yes, and negative 2, yes. So let's go ahead and do the last part. We're almost done. X minus 4, x plus 2 over x minus 4 and x plus 5. So what simplifies? Ahora sí. X minus 4, and we're left with x plus 2 over x plus 5. And don't forget your excluded values, guys. We have our beautiful fractions, or our beautiful factors, excluded values. Let me go and do it really quickly over here. X minus 4 equals 0. X plus 5 equals 0. Add 4, that's a 4. So therefore, x equals 4. And over here, we subtract 5, x equals negative 5. So we have these two values are my excluded values, which means that x cannot equal 4 or negative 5. That's a negative sign right there. There you go. Beautiful. Put your phone away, Mark. Thank you. All right. Everybody has this? 2 more, guys. We're down to multiplication, division, and we have our beautiful proportion. So again, be careful with your work. LCD, factor, LCD, factor. Okay. Okay. Everybody have this? There. All right, number 16, that's going to division. We're going to go and divide now our beautiful rational expressions. We're going to go and simplify our beautiful answers. So we have one fraction divided by another fraction. What happens when we have division? We're going to go ahead and keep the first one and flip the second one, change it to division. So now we have 1 over y multiplied by 5y, y minus 5. So this is my beautiful factor. Remember that, keep it together. Do not separate it. Okay. Now, once we have that, we're going to go ahead and multiply. Multiplication is very different to addition or subtraction. So remember, we're going to multiply from left to right. So it's 1 times 5y, which is 5y over y times y minus 5. Go ahead and keep it as separate factors. Do not combine them, guys, yet. Because we're going to simplify. Ahora sí, what simplifies? The y simplify. Do we have any, let's see, coefficients? We have 1 in my numerator, my denominator, 5 in my denominator. So it stays as 5 in my denominator. And, my numerator and my denominator stays as 5 minus, y minus 5. Do not simplify these, guys. Do not do that, okay? This is one single factor. It goes together. It doesn't separate. Keep it as one single factor. Ahí está. 5 over y minus 5. And that's it. Yay! Ready for the last one? Okay. Ahora sí. Clear. Last one we have to solve. So now we're going to go ahead and solve and check for extraneous solutions. Basically, we're going to go ahead and check for excluded values. Another word for extraneous solutions, guys, is excluded values that are also part of your beautiful solution. So we have one fraction equal to another fraction. So what do? Cross multiply. So let's go ahead and cross multiply. We have so we have x times negative 3x plus 6 equals to what? X minus 4 times x minus beautiful 2. Ahora sí. Let's go ahead and distribute everything nice and beautifully done, carefully done. So we have x times negative 3, negative 3x squared, x times 6, positive 6x equals our beautiful right side. We're going to go ahead and FOIL. So remember that we have our first two terms. So we have x times x, which is x squared, x times negative 2, negative 2, and then we have negative 4 times x, negative 4x, and then negative 4 times negative 2, positive 8. Let's go ahead and simplify very quickly. Negative 3x squared plus 6x. Combine these two terms. X squared, negative 2 minus 4. Minus 6x plus 8. Okay. Now remember that we have to solve a quadratic equation here. So one of the sides has to be what? Equal to 0. What side do you guys want to make equal to 0? Left side or right side? Left side. Okay. So it means that these values have to be the inverse of them. So I have to add 3x squared. Remember that we're going to go ahead and combine like terms. So it has to be underneath the next squared. So this goes to 0. We're left with 6x equals, we have, let's see, 4x squared minus 6x plus 8. And one more step to make one side equal to 0, subtract 6. Okay, this goes to 0. All right, so we're left with, I'm going to write it up here just because I'm running out of space. 0 equals 4x squared minus 12x plus 8. Let me write it the other way around because I like to see my beautiful quadratic on my left side. I'm just flipping the sides. That's all I'm doing. So I can see it this way. Ahora sí, what method do you guys want to use? Power Ranger. But notice all the terms. 4, negative 12, 8. What do they have in common? 4, so take it out. So let's factor the 4. We're left with x squared minus 3x plus 2 equals 0. What do we do with that 4? Divide it to both sides. So if we divide it to both sides, it simplifies on this side. We're left with x squared minus 3x plus 2 equals 0 divided by 4 is 0. Ahora sí, Power Ranger method. Much easier for us to do this Power Ranger method this way. Two values that multiply to 0 and add up to negative 3. Minus 2 minus 1 equals 0. So it's going to be x minus 2, x minus 1. So we have two factors. One of them has to be equal to 0. So we have to make both of them equal to 0. So let's go ahead and find out what values make them equal to 0. So we have x minus 2. Our solution is positive 2. X minus 1. Positive 1. Woo-hoo. Ahora sí. Extraneous solution, guys, means that we have to look for excluded values. So let's go ahead and do that very quickly. So what's my first denominator? X minus 2. So my solution here is what? x equals 2. And the second one is negative 3x plus 6 equals 0. The two-step equation. So we can go ahead and subtract 6. Negative 3x equals negative 6. Last step. Divide by 3, divide by negative 3. We're left with x equals positive 2. So therefore, x cannot equal 1. X cannot equal 2. Which one can we not include? X equals 2. So we're not going to include x equals 2 because they cannot equal to 2. So therefore, x equals to 1, where x cannot be equal to 2. So if there's a solution that repeats on your excluded value, we have to exclude that one, okay? Ahora sí, how do you feel about these better? Yeah, okay, all right. So Monday, guys, we're gonna go ahead and start with our beautiful final. Study your study guide, ask questions right now since we're here right now. Have your notebook check ready. I'm gonna go ahead and be calling you guys. It's gonna be on paper, so you have to show your work. No skipping. Everything has to be shown. If no work is shown, guys, no credit. And I don't want to take credit away from you guys. So make sure you guys show everything. Huh? With your work shown?
Yes.
Yeah. Huh? It's gonna be on paper. No. I'm gonna probably do quizzes, but just to give you guys like an immediate feedback so you guys know what you guys got. But I still have to go through your work. I have to see that you guys showed your work for it. Yeah. It's both basically. That's why, but I need to see your work. So that's why I want to make sure you guys get immediate feedback. And then at the same time, you guys show your work. So if you guys give me the answer, select it right, but don't show your work, I don't give credit. So you can have gotten the credit, but you need to show your work.
I didn't understand what you did at the end.
Which one? This one?
For the split values.
So you find your excluded value, ¿verdad? Eran those two denominators. This denominator and this denominator equal to 0. Aquí está, x minus 2 equals 0. And then 3x plus 6 equals 0. So we solve for this one, we get x equals 2. And we solve for this one, we also get x equals 2.
Oh.
So because x equals 2 is part of my solution, and it's part of the excluded value and it makes it undefined, we cannot include that one. But we can include this one.
Equals 1.
We can only include x equals 1, but we cannot include x equals 2.